with conditional statements. So everybody should have this handout. And we're going to go ahead and get started. Okay, you need a handout? Anybody else not get the handout? All right, everybody has a handout? All right, here we go. Can everybody read the handout for me real quick about what is a conditional statement? See? Yeah, we're going to have you take that test. So after this. Okay. All right, so now some basic skills that you guys are going to need. You're going to need to be able to solve these types of problems algebraically on your own. So I'm going to give you guys 2 minutes to solve those 6 problems. Some of them you guys can do them fairly easily. Some of you may forget how to do those. That's fine. We'll go over just basic steps, okay? Try to do the best you can to fill in the answers just right below it. And then any work, if you can, fill it on the left side first. That way that'll give you space. If not, the right side is fine too. But I'm only going to give you 2 minutes, okay? Already done. Perfect. If you're finished, start reading the examples right below there as you're waiting for me. Now you can start getting ahead. Read the examples below. Pay attention to the words we're going to start talking about, conditional statements. Those of you that are still working on the equation, that's fine. Those of you that are already done, just read through the examples for me while you're waiting. Okay? Okay. All right, wherever you're at, let's go ahead and take a look at the problems 1 through 6 real quick. For number 1, subtract 1 to both sides. And that gave you y is equal to a negative 1. Okay. Number 2, it says the absolute value of what number is equal to 2? X is equal to plus or minus 2. If you get the absolute value of positive 2, it's still 2. If you get the absolute value of negative 2, it's also 2. I do need to make a correction. There might have been an error back in elementary or middle school that the teacher told you to just change the sign to do that when you did absolute values. The only problem is when you get what's the absolute value of 10, for example? Just 10. So if you follow that rule of just change the sign, that's where you're going to be off. Here's what I need you to remember about absolute values. How far is the number away from 0 as a positive distance? Does everybody agree that positive 10 is the same distance from 0 as a negative 10 is? They're both 10 units apart. Absolute value is always a positive distance away. Okay? All right. Mm-hmm. Plus or minus 2 are both 2 units away from 0. Yeah, it has to be positive 2 and negative 2. All right, for number 3, subtract 15 to both sides, and you get z is equal to 2. That work right there should be fairly easy to do. Now here's, some of you guys want to cut corners. and you've gotten away with it before. It gets difficult if you keep trying to cut corners, especially with math, because most of the United States people don't like math. Okay, and I love it, and I want to show you how to just get through it. You don't have to love it or even like it, just understand it. Okay? So don't feel like, oh man, I gotta love that. No, you don't. Okay? I do. I really do. Okay? I enjoy it. Okay? Not everybody does. And that's fine. You don't have to. Alright? Okay. When you start to understand it though, it does seem easier. Okay? And there will be times. You guys saw on the logic puzzle, some of you guys might have struggled a little bit on the logic puzzle, and that's okay. But on the video, I explained through step by step how I'm getting to the answer. Okay? So don't worry if you struggle a little bit. That's okay. You gotta try, and you can make mistakes. It's okay to mess up. Okay?
What do you mean cut corners?
And what I mean by cut corners is when you're solving a problem that's simple like this, show that step. It just takes a second to do it. And you got enough room. I have enough room right there to show it. Now it does look a little bit sloppy, so my suggestion would be to, circle those answers.
What if you on solving number 3, I kind of had to put it z plus 15 equals 17 because I kind of get confused if it's not in order.
Z plus 15. Oh, okay, that's right. If you have to rewrite it like that, Z plus 15 is equal to 17. That is a good point to make. If it's easier for you to solve a problem where the letter's on the left, now just keep in mind that the equations are going to start to become a little bit more complex than that though. Okay? But as long as whatever's on the left side, if you shift it with whatever's on the right side and you just keep the signs and everything identical, you'll be okay. That's fine. Okay? All right, number 4, everybody should have got x equals -4. Take away 4 to both sides. Number 5, n is equal to just 0. And number 6, you should have got m is equal to -1. You should have added 9 to both sides. -10 and +9 give you a -1. Okay? If you get any of those wrong, my suggestion to you is spend some time extra going over basic rules of solving equations. Now, raise your hand if you did the diagnostic for me before class started. All right. Did I get to talk to you?
Oh, the picture?
Yeah, remember way back? Raise your hand again, those of you guys that did the diagnostic. Okay. You guys remember me telling you, okay, there's some things that you're going to have to get basic skills review on? Yeah? All that stuff is starting to come up. Okay? So just keep that in mind. Those of you that didn't get to do that diagnostic, just gotta roll with the punches, okay? All right. Unfortunately, the teacher might have forgotten or whatever, Okay. All right. Okay, next thing that I want to get to is some of the vocabulary that we're going to do. So, you guys have some highlighters. Sorry about that. I should have some more highlighters. There's another one here. If anybody didn't get one. Sorry guys, you guys get stuff. Extra? Yeah. Here's some other colors. Okay? Alright. I just don't have that many. They might have lost some of the Okay. Do you think that if I make you use highlighters, does it make doing something funner for you? Funner? I think that's probably not the right way to say it. Thank you. Always correct me, okay? Does it make it feel like you're actually, maybe you'll learn it if you use highlighters? Yeah? So, pretend I'm a commercial. Okay, pretend I'm a commercial. And I'm advertising I want you to learn, right? All right, man, if you guys are going to use highlighters, man, it's going to become so much easier because it's just going to stand out more and you're going to remember it. So I'm a commercial. And my commercial was, if you use highlighters, then you will learn the material better. Yeah? That's called a conditional statement. And it says, go ahead and highlight. If and then statements are a conditional statement. Highlight them. Okay? And then it says every conditional has two parts to it. The first part is, the part following the word if is called the hypothesis. So highlight that. So, if and then statements are called conditional statements. Now I did an example of a commercial, okay? Now some of you guys, do you have the TV where commercials are coming on every 15 minutes or so, and then they last for how long do commercials last? 2 to 3 minutes? Okay. In those commercials, they're trying to influence you probably to buy something, most likely. And the more creative they can get to make you look like, whoa, that was cool, that might make you want to buy whatever they're selling. Okay? Have you ever had a commercial that it was so good that you're like, I gotta go get that? What is it? Pillow pits. Pillow pits? I have 2 pillow pits too.
Of course.
So pillow pits commercials, you just saw that? And when you saw that commercial, you're like, I gotta get one of them. Yeah. Okay. Anybody else ever see a commercial and you're like, I gotta get that? Okay, coloring. Okay, all right. And everybody's in here different. You guys all got different tastes. Okay, so everybody's gonna like all kinds of stuff. Yeah. Yeah. So there was at point some stuff that you saw on TV that you're like, whoa, right? I want that. Yeah. Even if you couldn't afford it. Yeah. Okay. Well, that's what these conditional statements are. After the word if is always going to be what is called the hypothesis. Okay. After the word then is always called your conclusion. All right. Now, I want you guys to think about when you guys were probably 5th grade, 6th grade, 7th, 8th grade. I want you to go back to those grades levels real quick. Okay? And you guys remember always judging people? Do you remember doing that? Even if you did it in secret? Constantly? You're probably still constantly doing that? Yeah? We do that. Just part of our human nature. We're always constantly judging people. Yeah? And a lot of times people don't like being judged. Yeah? But you guys have been doing things that are called conditional statements your whole life. Since you were able to start processing and thinking things. When you were a baby, even though you might not remember it, you realize, because I know my baby does this, if I start crying, I'll get some, you know. So you've been doing this all the time. And now what I want to teach you is, remember on the logic puzzle that we were on the video I showed you? There were points in the video, if you go back and watch it, that I say, if this, then this must be true. My conclusion. If my hypothesis, if I'm thinking of something, then this must be a conclusion to what I'm thinking, okay? When I filled in that logic puzzle, that's what you guys were doing. You guys were doing if and then statements. You just didn't know, okay? And don't worry if you struggled with it, okay? It's okay. So they are kind of tough, okay? After you do some of you guys just got it down easy. Because your thinking is that complex. You're able to think complex things. Okay? Some of us, and honestly for me, it takes me a while. I don't just get it right off the bat. Some of you guys are probably way faster than me. Okay? And there's nothing wrong with that. Okay? All right, so we're going to identify hypothesis and conclusions on this section. Okay, so let's try one real quick. Everybody go to this checkpoint right here. Go ahead and read that statement to yourself quietly. And then do me a favor, underline the part that you think is the hypothesis and the conclusion from this statement that we read already. Highlight what you think, or underline what you think would be the hypothesis and what you would think would be the conclusion of this checkpoint. Alright, everybody should be finished? Yeah? Okay. Let's see, Derek, did you highlight anything in that statement right there? Or, I'm sorry, underline anything? What did you underline? Okay, t minus 38 equals 3. Okay, that was good. Did you underline anything else? What else? T equals 3. Okay, good. Those should have been the two things you should have underlined. Yeah? One of those two things is the hypothesis. The other one is the conclusion. So everybody real quick. You guys remember up here? What follows, or what should be in front of the hypothesis? If. So which one is the hypothesis? Alright, so just put an H right there. That's the hypothesis. The conclusion then is the t is equal to 41. So put a C there. We're just going to use H to mean hypothesis, C to mean conclusions. Okay? Everybody okay so far? Yeah? Now, do you guys understand that you're looking for the words if and the word then? After those words will be, after the word if will be the hypothesis, after the word then will be the conclusion. You with me? Okay. Alright, so you got two examples here to help you guys. And those are examples that you guys can use to go back and refer to. Okay. Let's go to the next checkpoint. Okay, go to right here. There's two sentences. And I just want you to read each sentence to yourself and underline what you think is the hypothesis and what you think is the conclusion. Okay, I'll give you a minute. There's two sentences, A and B, okay? You guys looked at right now, the first example that we did, identify the hypothesis and the conclusion. T minus 38 was the hypothesis, and T equals 41 was the conclusion. And then on the next problem, the integer ending with 0 was the hypothesis. The conclusion was that it's divisible by 5. And the one we just went over, if the figure is a square, that's your hypothesis. Then it has 4 congruent sides is your conclusion. This is what you guys are going to be doing right now. Identifying hypothesis and conclusion. Alright? Now you guys got all those examples if you need to go back to and review, okay? Alright, so we're going to practice a little bit. We're going to look at the conditional statement. We're going to figure out if it's true or false, okay? And I want you to get in the habit right now. I want you to underline, or you can highlight the hypothesis and highlight the conclusion. So go ahead and do that for the first one. All right, for number 1. Julie, what would you underline for your hypothesis? All right, so indicator, the word if tells you right after that is your hypothesis. What's your conclusion? All right. Is that true? Depending on the weather. Now, it was cloudy this morning. I don't know if it's still cloudy. It could be. There's been days that it's been very cloudy at 12 o'clock. And we don't see the sun. So, is number one a true statement or a false statement? At 12 o'clock, the sun is always shining.
False.
False. Because all you got to do is prove to me one time when the sun doesn't shine at 12 o'clock. And there's plenty of different examples, and it depends on the weather. Depending on the weather will determine if it's cloudy or not. Okay? So, number one then is a false statement. Can the sun be shining at 3 o'clock in the afternoon?
Yeah.
There's another false statement. Or there's another example to make that a false statement. Because just because it's 12 o'clock, that's not the only time the sun shines. Does that make sense? Okay. All right, go ahead and do the second one for me. Underline the hypothesis and underline the conclusion. And then I want you to determine, is it true or false, okay? And remember, all you got to do is think of one example that will make it a counterexample to what it's saying, and that makes it false, okay? This is how those logic puzzles are figured out, okay? So, everybody got number 2 already? Yeah? Elizabeth, tell me the hypothesis. Okay, car is full of gas. Now the word if is just like the indicator. You don't really have to use that as your hypothesis. Okay. What's the conclusion? Okay. All right. True or false? False. False. I'm sure you guys can give me plenty of examples of when the engine doesn't start, but it did have a full tank. Yeah. So. All right. Go ahead and do number 3. Underline the hypothesis or highlight it, and underline the conclusion or highlight it, and then read it carefully, and then make a decision. Is that a true or false statement? Don't shout it out. I'll ask the volunteers in a second. Okay, raise your hand, volunteer for number 3. Okay, or I'll pick on somebody. All right. Terrence, number 3. What is the hypothesis?
Number is divisible by 3.
Perfect. Sorry about that, bro. What's your conclusion?
Then it's odd.
All right, good. What do you think? Is that true, Terrence, or do you think it's false? You think it's false? Can you give me an example? 12? All right. 12 is a number, yes? Is 12 divisible by 3?
Yes.
Yeah, 12 divided by 3 is 4, right? So that part right there is true. Is 12 an odd number? So you gave me one counter example. That statement is false. All you need is 1. Okay? It's kind of like when you're with your friends, and if they lie to you, and you catch them in the lie, okay? If you catch them in the lie, from that point on, you're probably going to start guessing, are they always lying to you? Yeah? Okay. All right, go ahead and read number 4. Number 4 is a big. All right, number 4. Michael, you like this one, huh? Which one's the hypothesis? All right, drink milk. What's the conclusion? Good. All right. Okay, Michael, true or false? False. Can you give me an example?
Because we already had a big old discussion about milk 2 classes ago.
You can be strong with it.
You can be strong with or without milk. Can you lift weights and be strong?
When you grow, that's not fair.
Say it again.
When you grow, like, get taller, like,
And you get taller. I don't think that would be the cause of height. I think that's where genetics kind of that you got to go off your parents and kind of their ancestors. Yeah. So do you need milk to be strong then? No. You can lift weights. You can do exercises or other stuff, and you'll get strong because of that. Yeah. That's a good example. If you drink Red Bull, then you will get wings. That's what the advertisement says, right?
Because he drink too much, and he uses a record that's not
Okay. All right. So that's a good example of a conditional. Whenever you do the converse, can you put this in your notes? The converse switches the hypothesis with the conclusion. Make sure you put that in your notes, please. The converse of a conditional statement. Now, you guys already understand conditional, right? If hypothesis, then conclusion, right? Okay. So now that you can figure out how to identify it pretty easily after the words if and after the words then, right? If you're ever asked to do the converse of a statement, all you got to do is just switch the hypothesis with the conclusion. And here's how it would read. Instead of it saying if you drink milk, because drinking milk is the hypothesis, right? You would say if you want to be strong, then you drink milk, yeah? And that is a switching, and now that's called the converse. Now here's what's got to happen. When you switch the hypothesis with the conclusion, you also want to read the statement and also figure out, is that a true statement also for the converse, okay? So if you want to be strong, then you need to drink milk. True or false? False. Okay? Now, for number 5 and number 6, can everybody identify hypothesis and the conclusion for me real quick? All right, Daisy, what do you think the hypothesis is on 5? All right, good. That's your hypothesis, okay? And you can put a H there, okay? What do you think the conclusion is?
Then it is
Good. All right. If a rectangle has 4 sides the same length, now you got to remember, rectangles have 4 sides, don't they? If those 4 sides are the same length, is it true that then it is a square? Square by definition is all sides are congruent. Yeah? All right. Now, what if you had to write the converse of that? Go ahead, man. If a figure is a square, and just then make sure you add the word rectangle. Then the rectangle. Okay. If a figure is a square, then the rectangle has 4 sides the same length. Now that sounds kind of weird because you're saying if a figure is a square, right? A figure and a square, 2 different types of objects. They do have both 4 sides though. Yeah? Okay. All right. Number 6. And then hypothesis is what? Number 6.
Not sleep.
Okay, if you do not sleep, hypothesis, conclusion? Alright, everybody okay right there? Alright. Now we already did number 5 if it's true or false, yes? Yes? Did we do number 5? Okay. Number 6. Evan, you think that's true? If you do not sleep, you will be tired? Yeah, that's true. What if you write the converse of that? Okay, if you write the converse, you said if you are tired, then you did not sleep would be, I guess, the correct grammatical version of that. Is that true? Okay, I got yeses, and then I heard some false no's. Okay, could you give me a counter example to prove that?
You have your full sleep and you're working all day.
Okay. Does everybody agree if you could sleep a regular 8 hours, right? Go to work and get tired because you're at work physically, and that would make you tired, right? Not because you didn't sleep. Yeah? All jobs are different, okay? Yeah. So then, you notice if I write the converse of it, the statement then is false. Yeah? Okay. All right. Everybody take a look at number 7. Right back there. Focus. This part, because I need a little bit of room right there. To prove if that statement is true or not. You said add 4 to both sides. Does everybody agree with that step right there?
Yes.
To solve for x? Yeah. That'll give me x by itself. And 22 and 4 add up to 26. So this is a true statement as a conditional, right? What if I switch the hypothesis and a conclusion? It would read, if x is 26, then x minus 4 is 22. Would that still be true?
Yes.
Yeah. Because either way, when you solve the equation, x has to be 26, yeah? So I want you to start thinking about conditional. You guys understand sometimes the sentences will not have the words if and then. So don't automatically assume that if a sentence does not have the word if and then, that it's not a conditional statement, okay? Imagine if all commercials always said, if this, then this. Every commercial, they always said this. It'd get annoying, wouldn't it? If you buy this truck, you will be awesome. You know, every commercial actually does make that indication. If you do this, then this will happen. But they don't use the words if and then anymore because they're more creative now. They've got visual things that make you like, if you've ever looked at, in a commercial, their whole goal is they need you to spend the money on them. Whatever that may be. That's the ultimate goal. And if you do spend that money, they did their job. They got what they needed. Yeah? Okay? So that's how these if and then statements are going to keep popping up. They won't have the words if and then in it. Okay? You've got to start thinking. Now remember, how many of you guys struggled with the logic puzzle? Okay. If you struggled with the logic puzzle, here's what happens. When you struggle with those puzzles, it's because you got to start really thinking deeper of what do you actually know about the clues that were given. And you got to make if and then statements, okay? Do me a favor, make sure you go back and watch that video carefully on how I solved it, so that way you understand how your mind works, okay? All right? The more you guys start using your mind and your brain to go process things and try to work things out, you'll start to realize, hey, it just takes a little bit of time. Some of you guys are faster than others. That's okay. It's just your mind works at a different rate than somebody else, okay? And that's okay. You got to remember, your brain is a muscle. If you don't work it out, yeah, it's going to take longer, okay? It's kind of like if somebody's lifting weights every day, those muscles are going to eventually keep getting stronger and stronger. But if you're not using your brain to think about things, And sometimes they're like, ah, it's too much thinking. Well, that's because you're not using it constantly enough. So then when things do get difficult, then yeah, you got to keep trying. Okay? Everybody look at number 8. Can you just read number 8 carefully to yourself? Pretty safe to say everybody understands how to figure out hypothesis and conclusion at this point, yes? Yeah, okay. Hypothesis is right there. X, absolute value of x is greater than 0. Now, if for some reason, if any of you in here did not know that that's it, absolute value of x, that's something that we got to make sure. Those little symbols and stuff that you guys have to be able to read, okay. Very important. It says, if absolute value of x is greater than 0, then this part says that the number x was greater than 0. So I want you guys to think of a number. Okay? Think of a number. Take the absolute value of that number. Did you get a number greater than 0? Yes? All right. Was that number a positive number? Okay? All right. So do you think that's a true statement? Nobody thinks it's a false statement? It's a true statement? So if you think of any number, right? That number is always a positive number? Could I think of a negative number? So won't this still be true though? Absolute value of negative 10 is a greater than 0. Yeah, absolute value of negative 10 is a positive 10, isn't it? This is saying then the number you picked was a positive number that is bigger than 0. Did I pick a positive number? No. I picked a negative. So I found a counterexample to prove that there's not just negative numbers that are greater than 0. When you do the absolute value, that's kind of the twist. Okay? All right. Let's take a look at number 9. 8 is false. This one was true. This one was false. All right. Now, if we write it as a converse, do you guys understand we just have to switch the hypothesis with the conclusion? So if you pick a number greater than 0, so everybody pick a number greater than 0, okay? Automatically you're picking positive numbers, yes? Absolute value of any number that's positive is always going to still be a positive. So if x is greater than 0, then the number you picked is a positive number. Now, your number had to be bigger than 0. If you picked 0, you couldn't have done that, because that 0 is not bigger than 0. Okay? If you picked a positive number, then when you substitute, if the x is greater than 0, then x, absolute value of x is greater than 0. That makes it a true statement, because you're just saying only pick positives. As a conditional, it was a false. If it's true when you write it as a converse, it doesn't mean it's true both ways. It's got to be true as a conditional and a converse. Okay? Let's try number 9. All right, so everybody, number 9. Read number 9. All right, so you got to think of, you're going to square a number, okay? And it's going to be positive, right? Everybody think of a number. Now remember, there aren't just positive numbers in the number system. There's negatives, there's 0, and there's positive numbers. Remember, there's also fractions and decimals too, okay? All right, so everybody pick the number. Everybody got a number, make it easy. Okay, square it. Whatever you get from that, did you get a positive number after you squared it? Yes, did anybody not get a positive number? Okay. What if I pick negative 5?
Yes, that's positive.
Negative 5, when I square it, gives me positive 25, doesn't it? Which is a positive number. Then, did I pick a positive number? No, I picked a negative. So the conditional is false. What if I switch it and do the converse? If you pick a positive number for m, then m squared is positive. Is that true? Yeah. If it's true as a conditional and it's true as a converse, then it's true both ways. But if one of them is false, then it's false because it has to be true written as a converse and a conditional. Okay. All right, everybody go to number 10. Now you guys, the hypothesis and the conclusion, that's super easy right now? Yeah? Okay. The part that we're actually doing now, you guys are just thinking. Is this statement true or not? Now, do you guys realize some of these problems are actually going to involve a little bit of work now? Yeah? Okay. All right, for number 10, if y is equal to 3, that's your hypothesis, then 2y minus 1 is equal to 5. It's true? Yes? Now let's check it. 2y minus 1 is equal to 5. There's a couple ways you can check it. Solve the actual equation, right? Or what else? Plug in the number that they're saying y is. Now, when I plug in the number, what do I simplify that to be?
6 minus 1.
All right, 6 minus 1. Not done there. What's 6 minus 1? Does 5 equal 5? Yeah. That's a true statement, isn't it? What if I switch it and do the converse? If 2y minus 1 is equal to 5, then y is equal to 3. Is that true? If I solve 2y minus 1 is equal to 5, if I solve it, still true, isn't it? Add 1 to both sides first. That'll give me 2y is equal to 6. Divide by 2y is equal to 3. So it's true as a conditional. It's true as a converse, so it's a true statement. You with me so far? Yeah. Okay. Now, I'm going to leave these right here, okay, for you guys to work on your own, okay? And I'll leave these also for you guys to work on your own. But you guys get the hang of hypothesis and conclusion? Does everybody understand how you would write the converse of a conditional statement? All right. Derek, how do you write? What do you have to do to write the converse of a conditional statement? Yeah, just switch the hypothesis with the conclusion and just read it with if the conclusion, then whatever the hypothesis would be. So is that pretty easy? Yeah? Okay. You guys understanding how to figure out if the statement is actually true or not? Some of them are going to have algebraic equations in them, okay? Some of them are just common sense. You got to think about it, okay? Remember the one about the sun shining at 12 o'clock? You just got to think about it, okay? 12 o'clock, only at 12 o'clock does the sun shine? No. Does the word counterexample, does everybody understand a counterexample? All you got to do is prove one time that that statement is false, and that makes it a false statement. Okay? All right, so let's go ahead and let me see where I'm at. I'm going to leave the rest of those for you guys to work out on your own. Let's go to the next page. Because now we're starting to get into what this last, we're getting close to the end of the unit. I think I might end up having to use one more day though, so then we can take the unit test stuff. Okay? Alright. Take a look at problem number 1. It's a conditional statement. It's already told that it's true. It's asking you to consider the converse of each statement. If the converse is true and the conditional is true, everybody underline this, that is called a biconditional statement. If the converse is true and the conditional is true, that's called a biconditional statement, okay? Now, remember on the ones we just did, some of them were true one way, but not the other way. If it's biconditional, it has to be true forward and backwards as hypothesis and conclusion, and then you switch them, okay? All right. Now, do you guys notice we're starting to talk about some angles and stuff, some equations? Okay, so pay close attention, because the part that we're getting into right now is just the little part. We're going to actually have to solve some problems now. And here's the thing. You guys have to look at the pictures and be able to figure out what is in the picture that you know is true to help you figure out a solution. Okay? All right, so everybody, can you read number 1 to yourself, please? Read number 1 to yourself. Now, after you read it, you guys already know how to figure out which one's the hypothesis and the conclusion, right? You can underline that real quick. Go ahead and switch them and read it as a converse statement. And then I want you to think about it. Was it true as a converse statement when you switch the hypothesis with the conclusion? Now I'm going to read problem number 1 to you as a converse, the way you really should have read it. Now, if two angles have the same measure, then they are congruent. You guys understand hypothesis and conclusion, right? Here's how you read it as a converse. You want to try it? Okay, try it, Daisy. Good. That's good. Now, here's one thing I would have added though on the when you switched it. Instead of just saying if they are congruent, you got to be more specific. What are you talking about that's congruent? You would say if the two angles are congruent, then the two angles have the same measure. I would just add that because you want to try to be as specific as possible. But the way you said it was perfect. Okay. Just always think about being a little bit more detailed, okay? So if two angles are congruent, then the two angles have the same measure. Is that true? The definition of congruence means that they both are the same, isn't it? Is it true as a condition? The statement. Yeah. Is it true as a converse? So if it's true as a conditional and if it's true as a converse, that's called a biconditional statement. Yes? Which means it's a true statement. Okay? Go ahead. Now, how do you combine the sentences? In a biconditional statement, they're always going to use the words try using that in real life. If and only if. If you try to use that in real life, there are certain things that have to happen. You can't just randomly use. You're saying if and only if this happens. if you just think about using it in your life. Okay. A biconditional statement will always have that. It'll say if your hypothesis, and then for the conclusion part, it'll say if and only if. And then they'll say the conclusion. Okay?
So,
You would insert this right there. If and only if they are congruent. Yeah? Right. You're combining the inverse and the converse.
Like literally.
Oh, okay, yeah. I got you. All right, for number 2, it already made the statement. Everybody, if you look over here in the directions, it says the conditional is already true. They're saying it's already true, okay? So you don't have to figure out if the conditional is true. It's telling you it's already true, okay? All you got to do is do the converse of it. Is the converse true? If the converse is true, then that makes this a biconditional statement. And then you would add if and only if instead of the word then. You take out then, and you would write if and only if they are congruent. Okay? So go ahead and see if number 2 is true as a converse. It's already true as a conditional. Okay? Now you guys getting hypothesis and conclusion, that's super easy at this point? Yeah? Okay. Alright, so just switch those. And for number 2 is on number 3. If you do the converse, the absolute value of n is 17 because you're switching the hypothesis with the conclusion. It says the absolute value of n is 17. N is equal to positive 17 is a false statement because n could have been negative 17. And pay attention to this part. The absolute value of negative 17 is also 17 units away from zero. All right. So that's all you need is one counterexample to make it false. You don't need more than that. There might be more examples though. But all you need is one. So is number 3? We already said number 2 was a biconditional statement, right? Number 3, was it a biconditional statement? No. Okay, number 4, if a figure has 8 sides, then it is an octagon. That's your conditional, okay? Go ahead and switch it now. So, Michael, you say a figure is an octagon, then it has 8 sides. Is that true? Yeah. Anything with the word octagon, octa means 8. So it's true as a conditional, that was given. It's true as a converse, so it's a biconditional statement. Very important here, octa means 8.
So you can give it like octopus.
Octopus. Alright, so number 4 then is also true. Number 3 was a false. Alright, now we're going to start getting into the stuff that when you guys start solving these problems on this, when we finish Unit 2, you got to start thinking this way, okay? Alright, a whole number is if a whole number is a multiple of 5, if and only if its last digit is either 0 or 5. Does everybody notice they use the words if and only if in them? So right there, they're telling you this has to happen, if and only if, okay? So I want you to think. Think of a whole number that's a multiple of 5. Now multiples of 5, 5, 10, 15, 20, 25, and so on, yes? It's basically telling you what's the times tables of 5. Alright, so in the times table of 5, A whole number is a multiple of 5 if and only if its last digit is either a 0 or a 5. All right, in the times table of 5, do all the numbers end in either 5 or 0? A whole number is a multiple of 5 if and only if its last digit is either 0 or 5. Is that a true statement? Yes? Now I want to show you something. Everybody see up here? Natural numbers are the numbers that you start teaching babies when they're little. 1, 2, 3. So kind of get the idea where natural came from. Okay. After that, as you got older, then they introduced to you 0. That's when they told you, no, you can't have this. You can't. You're not getting anything. Yeah. Then you understood 0. Yeah. Then after that, that's when they taught you integers, which were all the negatives of those positive numbers. Yeah. So look at what are whole numbers then. Whole numbers include what number? 0 and all of the positives, right? So this statement is saying a whole number is a multiple of 5 if and only if its last digit is either 0 or 5. Isn't 0 a whole number? Is 0 a multiple of 5? No. It's only 0. 0 is only 0. Yeah? So is this a true statement then? It's false. And here's why it was false. Because they said the word whole number. Whole numbers include the number 0. No, it includes 0 and all the natural numbers. Yeah, because notice natural numbers are inside of the whole numbers. Yeah? Okay. Integers include the whole numbers and the natural numbers. You see how the outside includes all the inside stuff too? Yeah? Rational numbers include the integers, the whole numbers, and the natural numbers. Yeah? Okay. Now I want to throw something out to you. If you live in Victorville, then you live in California. Is that true? All right, that's my conditional, right? All right, do the converse of that. And you saying false? Is that, you guys agree? If you live in California, then you live in Victorville is false?
Yeah.
Okay, can you give me one example or a counterexample that why you're saying it's false?
Because not everybody lives in the
You live in Hesperia. Not everybody lives in Victorville. Everybody agree with both of those statements? Do you agree that there can be more than one counterexample? All you need though is one. Yeah? Okay. So remember, conditional statements don't always necessarily have to be true. They could actually be a lie. If you ever become a salesman, or you're trying to sell stuff to people, a lot of times you have to exaggerate things because you're making your money off buying something from you. And if you've ever met a salesman that's really desperately trying to sell you something, they're going to say whatever they have to say to make you buy it, even if it's not true. Yeah. Okay. So just remember at the beginning of the year I told you don't believe what I say. Always find the truth on your own, but just if you see that I said a lie, tell me, okay? Because don't believe what I said, okay? That goes with some of the stuff that I've been telling you guys. Look it up, yeah? Look it up, okay? All right. Number 6. Ooh. Can anybody read number 6 real quick to you? On your own, just read it quietly because there's a couple words in there that I'm not sure if some of you might recognize them. Okay.
lines like X.
Okay, intersecting lines at X. Okay, try to be a little bit more specific, and they have to be straight lines. Okay, 2 lines that intersect. And what else? If they're perpendicular, it has to be specific. they have to make what kind of angles? Right angles. If they don't make right angles, then they're not perpendicular. Right angles measure how much? 90 degrees. Perpendicular lines. Just think of the x and y axis. Those two lines are perpendicular from each other. They make 90-degree angles. All right, so now can you visually picture what that word is saying? Yeah? Okay. So, if two lines are perpendicular, they look like this. Here's my y-axis. Here's my x-axis. They make a 90-degree angle. Can you guys picture that? Yeah? Okay. So if two lines are perpendicular, if and only if they intersect to form four right angles. Four right angles are in a square. When two lines intersect and they're perpendicular, does that make four right angles? Yeah. That has to happen when lines are perpendicular. That one's 90, this one has to be 90. These two have to add up to how much? 180. These two have to add up to 180. These two are called what? Starts with a V. No, not vertex. Vertical angles. And these two are vertical angles. Four right angles. Yeah? And 360 is all the way around a point. Okay? So if two lines are perpendicular, if and only if they intersect to form four right angles. So when you rewrite it as a converse, if two lines form four right angles, then they are perpendicular. Is that true? Mm-hmm. That is a true statement forward and backwards. Really important that you guys are, some of the stuff we're doing right now is just kind of a mental thing. You're thinking about it. Very important that you're going through the process of trying to think to make sure you're figuring out if it's true or not. Okay? All right. If you live in Texas, that's my hypothesis. If and only if you live in the largest state in the contiguous United States. Now, the word contiguous might sound a little weird to you, yeah? Because it's a word you don't normally use. Yeah? Any of you have an idea what you think contiguous would mean? Okay, continuing, okay. Right there. You see how words, if you don't know what they mean, then you don't really completely understand the sentence? Contiguous kind of sounds like continuous, doesn't it? Now they're talking about the United States, so I want you to picture the United States. Now, I used to have my maps all over the place. But the United States. I'm trying to draw it as best as I can. Now there's other parts of the United States. Now did you see how I drew kind of rough sketch of the United States? What part of the United States is just continuous? What's this one?
That's Hawaii.
That's Alaska, and actually I forgot Hawaii. Yeah, Hawaii's over here. I forgot Alaska, right? Or I'm sorry, I forgot one of those two. Are those continuous to the other one? No. You see they're not attached? They're out. Out? Okay. So do you think maybe contiguous United States, they're only referring to the ones that are all connected? Does that make sense? Yeah? All right, so now I want you to think. Now that you understand contiguous, right? I only want you to think of the states that are in the United States that are connected with each other. So now we're talking about just, that's right. So that section of the contiguous United States. If you live in Texas, then you live in the largest state in the contiguous United States. You think that's true? I believe Texas is the biggest state in the contiguous United States. Alaska and Texas are the probably two biggest, I think. But do you understand that Alaska is not connected to the United States? So do you understand why they threw in that word contiguous? Yeah? All right. So if you live in Texas, then you live in the largest state in the contiguous United States. That's already told you as a true statement. When you flip it, if you live in the largest state in the contiguous United States, then you live in Texas. True. Now, I don't believe there is another state bigger than Texas that's just in this part. Yeah? I don't think so. California is probably the second biggest state.
Most expensive.
Florida, I'm not too sure about who would be the next after, but I'm almost positive Texas is the biggest one out of these. Okay? Right. No, I used to have them all over the place, but I lost it. Read and focus with me, so please, no distractions. Don't worry about the law of detachment and what it actually, the definition is. You're not going to have to know that yet. Not yet, okay? I just want you to read the sentence number 1 to yourself. Okay? If two angles have a sum of 90, then the two angles are complementary. Is that true? Wait. You just said it equals 180. Complementary does not equal 180. Supplementary equals 180. Complementary adds up to 90. That's from the last class, yes? Okay. So, number 2, if the football team wins on Friday night, then the practice is canceled for Monday, and then it says, the football team won by 7 points on Friday night. So what's going to happen? Practice is going to be canceled. This is how you guys are going to do conditional statements in real life. You got to read what was given. If an outcome actually happens, then you should be able to figure out the next one. What if somebody that was at the game comes to practice on Monday? Nobody's going to be there. Because the coach said, if the football team wins on Friday night, then their practice is canceled on Monday. So that person isn't paying attention. Yeah. All right, number 3. If a triangle has one 90-degree angle, okay, now you guys know that if one of the angles in a triangle is 90, the other two angles have to add up to equal how much? 90. No. One of the angles in the triangle is already 90. If we know the other two are equal, then yeah, they would both be 45. But whatever this one is and whatever this one is, those two have to add up to 90. Remember that rule? How much should all 3 of them add up to? 180. Okay, read it carefully, okay? It says if a triangle has one 90-degree angle, then the triangle is a right triangle. That is true, automatically. The minute one of the angles is 90, that's considered a right triangle. Okay? All right. Now, what we're doing right now, for some of you, if you're not paying attention, this is where you're going to lose things, because we're just going over basic things you should already know. Okay? Now, I'm going to leave you guys to read those on your own. Okay? 7 through 12. Yeah. And make sure you understand those. Okay, let's go to this next page. Symmetric property of equality. So you're going to fill in some stuff. So pay attention. Okay? If MN is equal to UT, symmetric property of equality, what do you think symmetric is saying? Perfect, okay. Symmetry, okay. You guys remember line of symmetry, right? They're mirrored. So if Mn is equal to Ut, then what would be the mirror that? Okay, you can say Tu equals Nm. Okay. You guys agree right there? You could have also said Ut instead. Ut is equal to Mn, yes? Okay. Now remember the 2 points. Remember when I was highlighting the angles in one of the previous handouts? I was telling you pay attention to the letters that you're highlighting because that's the way you're going to read that angle. Okay? All right, division property of equality. So if 4M, which is angle QRW, is equal to 120, then, and this is what it's saying, if 4M is equal to 120, then division property, use the division property of equality. So go ahead and write 4M equals to 120 on the side over here for it. Use the division property of equality. So I'm going to do something real quick. I'm going to always keep putting up those 4 symbols to remind you this is all we're doing. We're adding, subtracting, multiplying, or dividing. Please, please don't confuse the rules of adding and subtracting with the rules of multiplying and dividing, okay? If you mix those up, that's where there's going to be errors when you're doing simple algebraic math, okay? All right. What would be the division property for this equation? What step would that tell you to do? Divide by 4. And it's equal to 30. So, by the division property of equality, if 4M, which is angle QWR, is equal to 120, then what would you write right there? M equals 30. Okay? Now, does everybody see the work I showed on the right there? Where that's coming from? Okay? All right, so division property of equality, there's also multiplication property and division have the same rules, don't they? Addition property and subtraction property, they also have the same rules. When you're adding, it's really the same as when you're subtracting. When you're subtracting, you're just adding negative numbers. When you're multiplying, that's still considered division because division is multiplying by a fraction. So they're still the same, okay? All right, transitive property of equality. This one's a little bit different, okay? Look at what it says on your handout for transitive property. Not translating, kind of like a transformation. You're moving. Yes, you're moving. Okay, so now watch. If SB is equal to VT, right? And VT is equal to MN, what else do you know? That's already. SB is also equal to MN. That is by the transitive property. Do you see that you related one to the other? They both had a common VT in common. So do you understand that in the transitive property, you're going through a couple different relationships to relate to one to another? Okay. All right, addition property of equality. Now, addition property of equality and subtraction property of equality, you're kind of doing the same thing. Subtraction is just addition of a negative number. Okay? When you're doing that property, and whenever you're doing division property, multiplication property, addition property, or subtraction property of equality, it's because you're going from one side of the equal sign to the other side of the equal sign. Okay? So if you do the addition property of equality for y minus 5 or y minus 15 equals 36, what are you supposed to do then? Add the 15 to both sides. Y equals 51. So therefore, if y minus 5 equals 36, then how would you fill that in? Y equals 51. You start to realize that was some of the conditional statements that we were reading earlier? We're actually just doing the math to figure out what's the conclusion there. You notice it has a hypothesis and a conclusion? Yeah? Okay. All right, now, reflexive property. Reflective. Switching around. So now do you notice it has a bar over it? You got to pay attention to that because later on, that bar might end up being an arrow that's really called a ray, or it might have two arrows, which is a line. Okay? So if it doesn't have any arrows, that means it's just a piece of a line. It's a segment. Okay? So that's segment JL. What would be congruent to segment LJ with the formula? Reflexive. Sounds like a reflection, yes? You notice some of these words that we're reading, if you just think about it carefully, you kind of know them already. They sound like other words. Yep. Okay. All right, so 1 through 5, I want to remind you guys there's addition property, subtraction property, multiplication property, and division property. Remember the rules of adding and subtracting are the same. And the rules of multiplying and dividing are the same. Whenever you're going to move something on one side of the equal sign to move it to the other side, what's the opposite of adding? And you see it's vice versa. And what's the opposite of multiplying? Division and vice versa. Okay. Those things you got to remember when you guys are working with an equal sign, okay? Is that okay right there? Yeah. All right, so now look at number 6 and number 7. That one's asking you to give a reason for each step. So follow with me here. The first step is given. That's the reason for it. Okay? How did they get from the first step to the next step? So let's say this is step 1, step 2, step 3. How did they get from step 1 to step 3? They added, what did they add?
They added 4.
Perfect. That's called the addition property of quality. Now, you notice I abbreviated some of the words? I abbreviated addition, so a dot needs to go right after that. I abbreviated the word property, dot needs to go right after that. And instead of writing the word equals, I just wrote the symbol for equals.
Which way you can get it?
So, do you guys see that when you guys start writing in this class, you're going to start using kind of like a texting language?
Yeah.
Yeah? Okay. And it's very important that you understand what the symbols mean, because then you can use the symbols as part of your writing. Okay? So it's just like texting. When you guys do that on your phone, it's just a math language of texting. Okay? So for everybody okay with that second step? All right, how did I get from step 2 to step 3? Divided by 7. So the reason would be division property of equality. Does that make sense? Everybody okay right there? Now the only thing they're not showing here is that actual step of dividing by the 7 there. Can you see that though there? Okay. Okay. Now, do you notice that the questions are asking us for proof of why did they go from here to here? Yeah? It's another thing that was happening when you guys were doing the logic puzzle. You had to prove why could you circle that square and instead of X it out. You know, you're trying to give reasons to stuff. This is called logic. When you think logically, you're trying to find truth or a truth to it. If it's not truth, then automatically you consider it false. If you can find one counterexample though, that'll make it a false statement. Okay? Alright. Now I'm gonna have you guys do number 7 on your own because I'm kind of running out of time here. So let's move down and 14. I'll have you guys finish all the way up to 12 on your own because I'm kind of running out of time right now. Alright, on number 13 and on number 14, this is what you're going to start to see on the actual unit test. Okay? So I want you to, everybody look at number 13. Look at the picture carefully. Look at the symbols in the picture so that you can figure out a way to solve for the variable. Okay? Now there are some symbols in number 13 that everybody, I'm hoping, automatically is recognizing. Yeah? Okay, I got a couple nods. Somebody raise your hand. Tell me something in that picture that is important.
Right.
Okay, everybody agree right angle in there? Right angle is important. Right angle measures how much? 90. Okay. Something else in that picture is very important that you are able to distinguish. Does anybody have an idea what else is in that picture? Raise your hand if you can. And I kind of want to get people raising their hands so I don't have people shouting out stuff. What do you think, Danny? What else do you see in the picture?
The line.
There's a line. Can you give me some letters that make that line?
W and T.
All right, W and T is very important. You notice that W and T splits that right angle into 2 angles? How much should those 2 angles add up to equal? 90. So do you see now you can write an equation? What's one of the angles? 2x, yes? And you guys see the other angle is x plus 6? 2x plus x plus 6 should add up to equal how much? How much? 90. So go ahead and fill that in. 2x plus x plus 6 equals 90. Does everybody understand how we fill that in? And that was just in the clues on the picture. How would you get from that step to the one below it? What do you, and be specific on what you have to do, Julie? Combine like terms. You guys understand that there's a 2x plus an x plus 6 right there? But you don't need that parentheses anymore because this plus sign isn't changing it. When you combine like terms, which terms are the same? 2x and okay, what do those give you? 3x. Okay. What do you think is going to happen from that step now to the next one? So you're already going to the next step then? Okay, the next step should fill in with what? Equals 84? Okay. Tell me how you got the 84. What did you do?
Subtracted 6.
Okay, good. To get to the next step, you're supposed to subtract 6 to both sides. That gives you the, this is what you had said right there. 3x is equal to, how much?
Oh, wait, what?
What you said 3x equals 84. That's what those right there. Everybody with me right there? What's the last part? Because it says x equals something. How do you figure it out? Divide by 3. And x equals 28. 84 divided by 3 looks like that, by the way. Okay? 3 goes into 8 2 times with the remainder of 2. 3 goes into 24 8 times with the remainder of 0. So x is equal to 28. Could I figure out what this angle measures? Yeah. What would I do? This says 2x, but don't I know what x is already? So plug x into there. What's 2 times 28? 56. This angle measures 56. Can I figure out this one? 28. 28 plus 6 is 34. Those two angles should add up to 90. Yeah? Alright, so now I'm going to leave you guys with some problems to work on. 14, you're going to finish that, but you're also going to learning shortly on time here. On the next page, does everybody remember problem number 1 from way back? When we started Unit 2? What kind of picture and what is it telling you in that picture for number 1 on that problem? How would I solve for x there? Because I got to look at the picture. I need you guys to think, when I started Unit 2, what did I start showing you guys? Stand up. Pick up the word. What do you know about these two? Say it again? Okay, they are equal, yes. Why are they equal? What is the name of that? Say it again? They're vertical angles. Vertical angles are always equal. So that means 3x minus 40 is equal to 2x minus 10, and you can solve for x. What about number 2? What do you know about that picture?
Straight lines.
Straight lines add up to 180. So that means these two angles are supplementary. They add up to 180. What about number 3? Okay, straight line again. All that should add up to 180. One of them is 90. Okay, let's stop packing. Don't pack because I'm not done. Number 3. How would I set number 3 up? Yeah, how are we going to solve for z? Okay, 90 plus 4z minus 10 equals 180. Something's wrong with that. You forgot the other angle, which was just z. All 3 of those angles should add up to 180. Now, if one of them is 90, shouldn't these two add up to equal how much? 90. So you could set that up too. Okay. How about, you see number 4, what you're going to do on number 4? One of them is 90. That means the other 2 angles should add up to equal 90. They're on a straight line. For number 5, do you see vertical angles? 65 equals what? No. 65 equals... Say it again? No. Okay. Now you guys are worrying me. Number 5. How am I going to solve for x? $65 equals what? No, not 65 equals x. I don't see an angle that just says x.
Oh, 4x plus 1.
Okay, 4x plus 1, that's one of the angles. What does that equal? 4x plus 1 equals 65. Okay, so 4x plus 1 equals 65. Those are vertical angles, yes? Now you can solve that equation for x. What about these 2 angles? Which of these 2 angles add up to? No, 7x plus 3 equals x, but there's no angle x here. 7x plus 3, and this angle, they're vertical. I don't know what this angle is. You notice these two are on the line and they're adjacent to each other? So adjacent angles should add up to equal 180. That means this angle plus this angle add up to 180. Or you could say these two add up to 180. Okay? Now, before we leave, very important, you guys have some work to do. All right? There is a back side to this handout that you guys are going to finish when you stop when you get to here. Properties of parallel lines. I'm going to do that the next class. Okay. So you guys got some responsibility to finish some problems and do that work. Please do not go home and do nothing because you'll start to fall behind.